not one of my really formal presentations that I normally do when I'm doing workshops, because StereoData Maker is all about hacking digital cameras. It's all about going in there and doing it yourself, though there are some options to just simply buy it. So if you have any questions as I'm going through this, please feel free to ask them. StereoData Maker started when a Russian hacker decided he would like to have access to some of the functions in his Canon camera that Canon wouldn't let him have, but he knew were there, like high shutter speeds and different apertures and bracketing shooting and things like that. So he spent about a year downloading the software, figuring out a way to get the software out of the camera, and decoding it, which is an incredibly labor-intensive, insane project to undertake. And what came out of it was something called the Canon Hack Development Kit. And it was a set of software that a real hardcore programming hacker could use to modify the software, the internal software that ran some Canon cameras. Fortunately, in the 3D world, we have people like David Sykes who are real hardcore programming hacker types. And he developed a version of it he called StereoData Maker. And the reason for the name is all it did originally was display data about the picture you were taking. Histogram information, depth of field information, a rangefinder you could use through the camera. And then he was talking to Mitsuni, the guy who does StereoPhoto Maker, completely different program. And he suggested, well, why can't we synchronize the two cameras together using this software? Since then, this program has suddenly become enormously interested. There are a lot of people doing it. And there's I'm sorry, am I loud enough for people in the back to hear? I have a really tough time with microphones, so I usually don't use them. And we don't have one here at the moment, so it's not an option anyway.
Move your hands more, we could hear better.
When I first started doing presentations, I had to actually go to a little class on it, and the person who was giving them to me, put your hands in your pockets, Steve. Stop doing this. What SDM actually does is add functionality to a normal camera. Its real purpose is to allow you to sync the cameras and to control the flash. Now, I have redone this presentation 3 times in 2 months. Do you know why?
Because they keep updating the software.
Because the software has completely changed 3 times in 2 months. And I have it on good authority that as I stand here today, this is out of date because a new version came out today. So you'll have to cut me a little bit of slack if you go back and discover that some of the stuff I'm telling you is no longer correct. SDM does not stay constant. It's something you're going to be playing with all the time if you really like it. It's getting new functionality. It's become enormously simpler to use. But you also need to understand what it does not do. It does not sync the focus on the cameras. It does not sync the exposure on the cameras. This last version added a way of syncing the zoom on it that sort of works. It does not power the cameras on and off for you, nor does it need to, because sync in StereoData Maker is completely independent of when you power the cameras up, unlike some of the other systems that we've used in the past for this. The other thing you've got to be really clear on is that it's only supported on some models of Canon cameras, and a camera is really a little PC inside. It has a lot of computing power, and it has software that it runs on. So when you buy 2 of these cameras, they may not have the same software in them. That's what firmware is in the world, the hacking world. You have to make sure you have the same version or a supported version. They can have different versions of the different cameras, but they both have to be supported by StereoData Maker. This means that when you buy these cameras for this purpose, you ought to make sure you can return them if they don't work. This also means that buying them on eBay is probably not your best option, since usually you cannot do a lot of returns there.
It goes without saying that this is PC only, probably.
No, it is not. The software itself runs on the Canon camera, so it's completely independent of what platform you're working on.
Okay.
The installation program works best on PCs. Now, I know most of the people in this audience probably are not that interested in the internal workings of digital cameras, but if you want to know how SDM works and why it works differently on different cameras and has problems, you need to know just a little bit about it. This is actually a diagram of one of the point-and-shoot Nikon cameras. I have a friend at Nikon who passes me on a little information. If it looks pretty complicated, it is. It has a CPU almost as powerful as the one that runs a laptop PC running in it. It's having to control things like the flash exposure, focus the lens, manage the CCD array, that's the actual sensor. It has memory, soft hardware, and buffer memory just like a PC. It's a very elaborate system. It's why in the past we've never been able to sync digital cameras. We haven't had access to all of that stuff. Now, in any digital camera is doing four things all the time. Maybe more, but at least four. It's sitting there looking at the keys. It's waiting for you to press the shutter. It's waiting for you to go into a mode button, do something like that. It's updating the LCD on the back unless you've turned it off. And it's checking the USB port to see if you're trying to download images from it or control it through the USB. It's also doing this wonderful box called housekeeping. Housekeeping means things like updating the date time, looking at the battery voltage, seeing if it needs to power the camera off because it's timed out. You know, a multiplicity of tasks. And when you press the take a picture button, you have no idea where it's at in this cycle. So if you take two cameras and you just press the buttons on both of them at exactly the same time to a microsecond, one camera may be updating the LCD, the other one is off here updating the serial number in the camera, maybe it's down here checking the USB port. It may be a second, half a second before it gets around to doing what you actually wanted it to do. This is why you see such a variation in the response time of the camera when you press the buttons on it. Now, the way we've gotten around this in the stereo world, like with the T200 rigs that a lot of us own, is you can go into half press mode. What happens there is the camera goes off and sets the exposure, and if you have two cameras looking at this room, they both see a slightly different exposure, so they may take a slightly different amount of time to calculate the exposure and to calculate the focus. They're still doing this check keys thing because you may change your mind and let go of that button. They're still out here doing the update LCD, and on a lot of cameras they're still doing all that housekeeping junk that was going on. So this won't really sync the cameras up. What will is if you put it in focus lock mode. After both cameras have the exposure set and both cameras have the focus set, they go into a limited software routine where they're updating the LCD, they're checking the keys to see if you've changed your mind, maybe they're off here doing some things we don't know about, and they're waiting for you to press that button and take the picture. This is the way all our P200 rigs work, and almost every digital coupled rig that we've made works. And it works pretty well. I love my little P200 rig. Its sync is about anywhere from 14 milliseconds to 100 milliseconds if you actually measure it. Now that's good enough for walking around and taking snapshots, but the minute you start trying to capture motion, you run into some real problems with it. And I think it's a limitation we've all seen. So how do you get around this? Well, let's talk a second about how SD works, and then we'll get there. First, you have to understand this was not designed into the camera. What we're doing is hacking the camera, loading software in it that the original designers never dreamed was going to be running on it. And each model has been hacked by a different person. And they have made slight differences in how they implemented this software. So it's going to work differently on different models. It's going to work differently on different firmware versions on the same model. It's going to be a little bit erratic, and that's one of these things you just have to live with. If you look at the memory in a camera, it's really divided up into three sections. You have the place where the software is stored that actually runs the camera. And normally you never change that. Then you have a section of memory where the camera stores the data, your preferences you've put in. You want this menu to come up, you like this ISO setting, you put it in manual mode, where it keeps all of that information. And then it has a large area where it stores the images, it reads off the image sensor before it writes them out to the card, or whatever kind of storage device you're using. Good cameras, this is a really big area and it can store several images so you can take shots fast. Cheap cameras, this is a very small area, it takes a long time to write. What StereoData Maker does, when you put the card in with the program on it, it loads program code, the same sort of thing as the firmware running the camera, into this buffer memory. It then tricks the camera in thinking that this memory is part of this memory. So now, the CPU and the camera will start running the code we loaded for StereoData Maker. One of the nice things about this is when we turn the camera off, this goes away. These two chunks of memory go away. So if we've made a mistake, we've loaded the wrong software, the software has a problem, it's really easy to fix it. Take the batteries out of the camera, leave them out for about 30 seconds, put them back in, and whatever you loaded for StereoData Maker is all gone. You can start over again. The reason that we get the fantastic synchronization that we get out of StereoData Maker is a little trick in the code. What happens when you press the button in StereoData Maker is it brings a voltage signal up on the USB connector. Now, when it sees that voltage, it goes into that half focus lock mode I was talking about, like a normal camera. It goes out and sets the focus, it goes out and sets the exposure, and this can take a variable amount of time on each camera. It can take a long time, actually, in some cases. But sooner or later, they both get synced up. And when it does that, it goes into a mode where all it does is check that USB port to see that voltage signal go away. It's not doing anything else. When it sees that signal go away, it goes over here to the take picture routine. So instead of going off doing a dozen different things and you have no idea where it's at, we know exactly what both cameras are doing when you release the button. That's why it takes pictures on the release of the button. Jumps into this take picture routine. My little rig that I'm using, I've tested it. I get 1/5000th of a second sync on it very, very reliably, which is amazing. Flash, not so good. Other people claim a 20,000th of a second. I honestly don't believe it, though I've seen some of the numbers. But the parts to put together one of these rigs yourself. And this is the toy that we can all build ourselves. It's one of the reasons I got so excited about it. You need the camera, of course. You need the correct software, which is free, which can be downloaded from the website. You need an external battery and a switch and something to mount the cameras on. That's all it consists of. This is my little rig. I bought these two cameras. They're the A570s. They have image stabilization. My hands shake a little bit, so I love the image stabilization. I put this together out of parts laying around the house, and I understand, unless you're a stereo person, you probably don't have a Jasper Engineering dual camera mount bar laying around the house. You can use a piece of ruler or anything else for this. In about 2 hours from taking the cameras out of the box to taking my first picture with it, it really is, if you have moderate soldering skills and a few hand tools, you can do this yourself. You don't have to, but you can. This is a little plastic battery box from Radio Shack. It cost about 89 cents that I took the parts out of and put a switch into. You know, a little L bracket bought at Lowe's for about 20 cents. It's just amazing how inexpensive it is to do this. What you do need to understand a little bit about is how USB works, because it explains why different cameras behave so differently in StereoData Maker. Camera manufacturers have two passions in life: keeping the cost down and keeping the power consumption down on the camera, because those are the two things that people are most sensitive to, actually. And a typical computer uses, the CPU uses a controller chip to talk to the USB, the serial port you upload and download pictures with. And the reason it does that is this is a very power-hungry function. When you're running this function, the computer is using a lot of power. So what it really wants to do is power this down and not be using it at all. Well, to do that, it has to have a way of knowing when you plug the USB cable in. So each of these cameras has a separate little function block that just detects the fact you plugged the cable in. And it works very differently on different cameras. On one camera, 3 volts will work. On another camera, 5 volts will work. And the reason for that is there is no standard for this. The USB standard is very well defined. The standard for detecting how the cable was plugged in does not exist. So each model of each camera may be done a little bit differently. A camera manufacturer will make a major design change to save 1 cent in the production cost of that camera. So they're constantly fiddling with ways to make it cheaper, better, and faster. Mostly cheaper. They really don't care about standards that much, to be perfectly honest. If you want your cameras to work in StereoData Maker, you need to provide them with 5 volts and a USB connector for your switch. They'll work as low as, some of these cameras will work at 3 volts, The A570 has a buffer circuit built in it. If you plug a 9-volt battery into it, it'll probably take it about 6 months before the camera stops working. It will stop working though. You don't want to over voltage these guys. Our shutter switch, which is external to the cameras, is nothing more than a battery and a little contact switch. In fact, one of the most popular things to use is a LED flashlight, because you've got a switch on it, you've got batteries in it. You take the LED out and you wire across the contacts and you suddenly got a little shutter switch for this guy. The schematic for this looks as simple as it sounds. Your basic USB triggering switch for a StereoData Maker is a 4.5 volt battery, which is 3 AAA cells. You can buy a little battery pack that'll hold these, or the little coin cells. A momentary contact switch. It's an 89-cent item at Radio Shack, or it's built into your LED flashlight. And then you have to wire it across 2 or more USB connectors. One nice thing about StereoData Maker, if you want 50 cameras synced up, you can sync 50 cameras just as easily as 2, and with just as much accuracy. It looks really simple, and it is really simple. It's a really bad solution, though. And the reason for that is that 4.5 volts is marginal for triggering the camera. And what will happen is as the batteries start to discharge and that voltage goes down toward 4 volts, suddenly one camera will fire and the other camera won't fire. One camera will ignore the switch. It'll see part of the pulse, things like that. You really need to have the voltage regulated. Well, a simple way of doing this is to use a 6-volt battery, 4 AAA cells, or 2 of the little lithium coin cells, and then put 2 diodes. These are little semiconductor devices, each of which will drop the voltage by about half a volt. So now we start out with 6 volts, we drop it down to 5 volts, to give the cameras what they really want, and as this voltage starts slowly decaying on this, we probably get all the way down to about 4.5 volts before the cameras start working funny. That lets you use about 5% of the battery, so it's a little bit expensive for battery usage. But AAA cells are pretty cheap. Now, to put this in real-world terms, since I know schematic symbols don't mean a whole lot to a lot of people, okay, this is what the battery holder looks like. It's about this big. This is a little contact switch. It's about 1/4 of an inch on the side. These are the diodes. They're about 1/4 of an inch long, and you just cut the ends off of regular USB cables and wire them together at the other end to make your cable connectors. That is about $1.89 worth of parts, by the way, if you go and buy them at Radio Shack, the most expensive place in the world to buy electronics parts. About $1.89. A better solution is to use a 6 to 9 volt battery of some sort, still your momentary contact switch, and what's called a voltage regulator. This is a little chip that takes the input voltage and makes it be the output voltage, whatever you want it to be. And some of them can go up and down, so they can operate to very low voltage. They're very efficient at battery usage, and they always supply exactly the right voltage out to the cameras until they stop working altogether. Now, I personally prefer something to either work right or not work at all. The problem with letting that voltage drift down is you will get into a mode where it sort of works, and I hate that, especially when I'm taking pictures. In case you're wondering, no, it's not that much more elaborate. This voltage regulator is a little 3-pin device that's about 1/4 of an inch high, about 1/4 of an inch on the side. It costs about $1. So we've run the price of this up to do a fairly nice system to maybe $3. What I'm showing here are making your own USB cables. You can buy the little connectors that allow you to make your own USB cables. If you do that, you can do things like not have those big bulky USB cables on your camera, or get the cameras a whole lot closer together. This is the completed switch box on my camera that I've been running around shooting with. And you can see from the insides how simple the wiring on it really is. I wanted 6 volts, so I've got 2 of these little lithium coin cell holders in there. This little black thing is the voltage regulator. And everybody please bear in mind, we're talking about this little box right here. This is small. A switch that I mounted very simply by a little piece of perf board in one end. And it's a very effective way of doing this. It works as good as if you spend a lot of money on it. Now, me being me, this is phase 2. This is laying on my workbench at home waiting for me to do the programming on it. It uses a lithium coin cell. It has what's called a boost buck regulator, meaning it regulates the voltage down until it gets below 5 volts, and then it starts regulating the voltage up to get the most battery life. It has a microprocessor running it, an external flash triggering circuit so I can have an external flash, a remote cable release so that I can use a remote cable release on it, and provisions for 3 switches because I'm planning to go into the code and add the ability to zoom in and out without having to go through the gyrations you do today on these cameras.
So I'll take one.
I don't know if I'm going to get into the production business of this or not. I put the sizes up here because I thought it would be kind of fun. This is 2 inches by not quite 1 inch. This little circuit here has to be soldered under a stereo microscope because the leads on it are less than 1 millimeter apart.
How do
I
you
just
do
got
that
the
again?
crazies.
And where do you get the circuit for?
It was fabricated for me by a company in Bulgaria.
Oh, okay.
Send the stuff off to them. It's cheaper and faster than doing it in the U.S. I know that sounds
They probably got
crazy.
it from the CIA somewhere.
They might very well have.
So we up to $1.50 now?
The board actually costs about $12. The boost regulator circuit on it is quite expensive. The little chip costs about $6. So it drives the price way up on me. Now, in practical terms, you're not going to make that little board. What you are going to make maybe is the little USB switch. And the hardest part about it are the USB cables. So I want to go through what you're getting into if you make your own USB cable. First of all, it only requires moderate skill. This is not something you're going to put a lot of effort into that you need to be an expert to do. And the one thing I would like to warn everybody about is buying pre-made splitters. If you go wandering out there, you can find some things that look like they're USB splitter cables. They have the male end on one end and the correct ends on the other end, and they look like the perfect solution to your problems. Most of them don't have the right wiring inside because they're actually designed for something else. And some of them have active components like resistors and capacitors in them because they're designed for something else. Chances are they're not going to work. This is what a USB cable looks like. I mean, we've all got them on our PCs. You know, this guy right here is the connector for my little guy. And that cable can be anywhere from 1/8 of an inch in diameter to 1/4 of an inch in diameter, but inside they all look alike. When you strip back this little piece of plastic covering, you find a braided wire interior. You strip the braided wire back and you find this aluminum foil neatly wrapped around the inside of that. And this is because USB is designed to operate at extremely high speeds. So it has a lot of noise blocking in it, a lot of control for noise. We're not doing any of that. We're operating at extremely slow speeds. We don't really need any of this. And then when you get into it, you're going to find 4 little wires. That's a millimeter ruler those wires are laid next to, because I don't want anybody to get shocked when they open this up and discover the wires are less than 1 millimeter in diameter. They are quite small. There are 4 of them, and we're only interested in the red and black wires. The green and white wires can be simply cut off. The cables that we're using for StereoData Maker makes no use of them. You would think, okay, they're less than 1 millimeter in diameter, they're going to be a nightmare to work with. They're actually not. If you want to make your own cables, you can also buy these little connector kits. Now, these are really hard to find, so I've put the part number and the person you can order them from in the handout in case you want to go try it yourself. The little kit, which consists of these 3 parts, costs about 89 cents. The gotcha is you're going to have to buy $20 worth of them because nobody sells them at onesies. And when you open it up, this is the end of the connector that goes into the camera. This is the end of the connector. It's actually the backside of that you solder to. Now, notice again, these things are about 1 millimeter wide. If you've got a decent pair of magnifying glasses or a decent vision, you can solder to this without too much trouble. You can also throw this part of the shell away, bend that part backwards, and this thing only extends out of a normal camera by, a couple of millimeters. So you suddenly have got really good, close connection without having to do a whole lot of fancy work. And I know what you're saying, no, I probably can't solder that. Well, actually, you probably can. What you end up with is something that looks like this. Now, that strange little blob is after you've soldered these wires to that connector, there's nothing to hold them on except the solder. And it is going to break. So what you're going to do is take hot glue, like from a hot glue gun, and put a little drop of it on it. Or you can take an epoxy putty, of what this is. It's sold in modeling supply houses for working on model airplanes. And it forms a really good insulator and will hold those wires on as good as something that was built in the factory. The tools you need to make these, all you need are a pair of cutters, needle nose, a soldering iron, solder, of course, a digital voltmeter, which you can buy for $6 or $7, because all you're doing with it is checking continuity to make sure you didn't short anything out when you built this. And this little pair of wire cutters. This is one of those deceptive tools. This is a master tool for doing electronics work. And you can buy them for about $1 in a bargain dollar store, something like that. Don't. You can go to Radio Shack or Lowe's or Home Depot and you can buy it for about $10. Has a little set screw on it here. You take that set screw, you take the wire you're going to strip, a longer piece, so don't worry about it, and you move that set screw and it controls how wide these jaws open. And you keep moving it until you can close it without cutting the wire in half. When you've done that, you just put it around the wire and pull on it and it strips it. So even though you're stripping a sub-millimeter wire, you can do it reliably and repeatedly if you just have a little patience and buy a decent quality wire stripper. From there on out, this is really pretty simple to do. If you don't want to build your own, you have another good option. It turns out that Ryco made a remote for one of their cameras that uses this same USB switching technology. It just switches the voltage levels on the remote control. I think this is like a $29 item, $30 item. I haven't bought one. You can buy it from, it's a current production item. You can buy it from almost any photo store. It uses a single AA cell and has that boost regulator circuit in it. You can either use an external splitter on it, or this is a picture of one of them opened up. You can go in and simply wire another cable across the connectors on it where the existing cable is to get two cables coming out of it. Now you've got a nice little switch, it's got a nice battery in it, you've got two cables coming off of it, and all you have to do is do one set of wiring on it. This is what it looks like in use. Here we've got both cables coming out, and a right angle adapter will let you put the cameras closer together. If you don't want to make your own ends for the other end, you can use a right angle adapter, and that'll slide them together. And see, that's a fairly nice looking rig. It's got an on-off switch to kill the battery voltage. It's got the shutter release on the top, and it's a half-press deal like we're used to on digital cameras. Half-press for focus and full-press to take a picture and release. This is a really good option to do this.
Which camera did you say?
That's a Ryco remote control. It's called.
It only works with one camera?
It only, well, it works with all of the SDM cameras, all the Canon cameras that work with SDM. It only works with one Ryco camera. Ryco never had any intention that you would be doing this with it.
It'll work on the Canon camera.
It'll work. It makes a really good switch for SDM. Now, if you don't want to do any of this, there's a guy in Germany named Werner Hughes. I don't know how his last name is pronounced. He simply sells these rigs. He's got a very nice little box. It's got a button on it. He uses two of the little coin cells, brings two cables out. You don't have to do anything except plug them into the cameras. So you can get up on your SDM rig by buying two cameras and plugging this in. I think he sells this for like 60 euros, so it's about $90, something like that.
I think the switch itself is actually cheaper.
It's actually cheaper.
I think it's about half that.
About
Yeah,
half that.
Yeah, it's,
Yeah, I've talked to him a little bit, but that's right. He makes one that has a whole lot of elaborate stuff in it, like a flash controller and stuff. It's a little bit more
the
expensive.
basic one is pretty cheap.
Basic one is pretty good. You do have to mount the camera, of course, but that's just like any other two cameras you're putting together. You can do it with a professional slide bar. You can buy a Z-bar from somebody. You can buy this cool little face plate gadget that people use. Or you can mount it on a piece of wood, like one of the guys at our club in Atlanta just put it on a yardstick. A couple of holes in it. This is where the problem starts for a lot of people, though. You've got this, you've downloaded your software, and you loaded it, and nothing happens. Because there are actually a few little gotchas in getting StereoData Maker running. The very first one is your SD card has to have a write protect switch. The reason this whole thing works is Canon put a feature in their software to load new firmware into their camera. When it sees a memory card inserted, the write protect switch on, and the right buttons pressed on the camera, it will load that software off that card into the camera. A lot of the SD cards you buy, especially the cheaper ones, have given up on that little write protect switch. You have to have a write protect switch to use it. Up until a week ago, if you had a card with more than 2 gig on it, it was a big deal. Today, it's not a big deal anymore, but it's still a little bit simpler to do it. The way you start this guy up, you take your card reader, something like this, and you plug your SD chip into it, plug it into your computer, and you run this program, StereoData Maker install. It goes out and formats the SD card, loads the software on it, makes it bootable. You tell it whether it's the right or left version of the software for your camera, and that's it. Put it back in the camera, remembering to leave put the write protect switch back on. start it up, and you're taking pictures. It's a very, very simple procedure. When they first released this, starting up to take pictures was about 12 steps. Now,
Steve, point 3,
Yeah.
format cards, do you have to do that step?
you don't have to do that anymore. I still do because I always format all my memory cards in the camera that I'm shooting them in, whether it's for StereoData Maker or in my Nikon or whatever it is. The cameras just seem to work better for me when I format the cards in the camera itself instead of formatting them in the PC.
And actually, I've never noticed a switch on an SD card. And so you're saying, so to load the software, the Write Protect has to be off. Once you've installed it, you turn the Write Protect back on.
Yeah, but, oops, do that. What David's talking about is on the SD card, and I know nobody can see this, I should have done a drawing of it. Right here on the side of this card, there's a tiny little white dot, little switch. And you can move it into 2 positions. When it's down, it's in the usable position. When it's up, it's in the Write Protect position. That's it. This is what we're looking at. All of the Canon cameras use this SD card. All the ones that StereoData Maker uses. And it has this tiny little switch on it. I'm sure you can't see it, but there it is. It's just a tiny little white dot. And in order for it to work in StereoData Maker, it always has to be on. I mean, this is counterintuitive because you're saying, oh, it's write protected, I can't use it in the camera to take pictures. Well, you have to have it write protected to use it in the camera with StereoData Maker. If you accidentally boot up without it, the camera will go into its normal routines. It won't run StereoData Maker, and you'll be sitting there saying, what's going on? What's going on is you forgot to put the write protect switch back on. Steve?
Oh, one quick question. Making one right and one left, I've loaded it in there. It seems to work, but I don't remember doing that, making one right and one left.
The question there, you've always been able to make one right and one left, by the way, but you had to go into the menus in the program and tell it, this is the right camera and this is the left camera. And the reason you did that is it controls how the flash works. We have software in StereoData Maker that tries to eliminate the dual stereo shadows that we get when we fire 2 flashes on point-and-shoot cameras. And in order to do that, it has to know which camera is the right camera and which camera is the left camera. And I think I've had more questions asked about that than anything else. What actually happens when you take a picture is it does a pre-flash on both cameras because it uses that to set the white balance. It then, on the left camera, sets the flash power at 10%. And on the left camera sets it at 10%, and on the right camera sets it at 100%, and actually takes the photo. So you see the flash firing on both cameras, and they look like they're out of sync, because usually one of them will be when it does that pre-flash. But when it actually shoots, they're in sync. It's only one flash, but it's a 10th power flash on one camera and a full power flash on the other camera.
When you do that, you end up putting on, telling both cameras that they're to take a flash shot.
The latest version of StereoData Maker is fully automatic. If you have the auto flash setting on your Canon camera using the normal Canon control keys, StereoData Maker picks that up and takes it in whatever flash mode you've set it up for.
What if you put it on forced flash if you wanted to?
In forced flash, I'm pretty sure, at least on my A570s, you have to remember something. Anything I tell you, I guarantee it on the A570, and I do not on any other camera, because I don't own them, and they work slightly different on all the other cameras. On this set, if I put it in forced flash, it works fine. All the flash modes work.
On the new 1.71, it asks for left or right, and you automatically do it.
It makes it very easy on the new one. When you're booting up and you're installing this software, you have a little checkoff box, left or right. Now, what is a good idea to do is to mark these little chips, left and right, so once you've done them and you walk into where your cameras are, you're not sitting there going, which one is it? Peter?
Yeah, is there any extra complication if you have multiple cameras beyond just 2?
If you have 4 or 5 cameras, and Bill Mull is building a 4-camera rig, it works exactly the same way. The only complication is this little battery pack that's supplying the power to do this. It takes about half a milliamp. These cameras take about half a milliamp when that button is pressed. The little button cells, like the lithium coin cells, are only designed to output very low current levels. If you put 10 cameras together, there's not going to be enough current to drive all 10 cameras. You're going to need a much heftier battery. That's the only complication. Other than that, the software doesn't. Remember something about the software on this. It doesn't know the other camera exists. All it knows is that USB signal. It doesn't know whether there's one camera, two cameras, or 200 cameras. It's the strength of the software. It's the fact that it is completely standalone and independent.
At what point here do you set the right protect switch on, and do you ever turn it off?
Okay, when do you set the right protect switch? Okay, you start out when you're loading the software with the right protect switch off, because the PC will not write to the card if the right protect switch is on. You run this SDM install program, and then you take it out of the card reader and you immediately put the right protect switch on, and you do not take it off again until you're ready to write to this card in a PC. As long as it's in the camera, you never have to do that. The reason why you do it immediately is otherwise you put it back in the camera, you put the cameras back together, you get them lined up, you go out to take a picture, and it comes up in normal Canon mode, because as long as this right protect switch is off, it only runs in normal Canon mode. And I've done that about 50 times.
You can store pictures in a right protect mode.
Yes. All this right protect switch is, let me, a little bit of inside information. All this right protect switch is a little bit set in a register on this card that says, hey, the right protect switch is on. Whether the software that's reading the card pays any attention to it is entirely up to the software. StereoData Maker simply ignores it. Taking pictures. Now, when you actually go to take a picture, remember what I was talking about, how this works. It's watching that USB connector, and it's watching for the signal to come and then go away. So, I don't know if I can put this back together now. When you press the button on it to start with, you're always firing on the release, and you have two options. You can press the button very quickly, and then release it, and then press it again, and it will take a photo. Or you can press the button and hold it down, and it will take a photo. Put this up directly. So let's do that here for a second, because I think this is the place where everybody gets real confused. Now, you can always tell whether you've done this right, but this little screen comes up. Did anybody notice what I just did? The very same thing I was telling you I do every time I take these apart. I put it back in with the right protect switch in the off position. Camera went up in the normal software mode. Okay, if you do something like that, always power both cameras off and start them back up at the same time. I don't know why, but for some reason they seem to be happy when you do that. Okay, now we've started up, and you see the little screen comes up to tell you that you've got StereoData Maker loaded. The left-hand camera has a red bar, the right-hand camera has a blue bar, so you can tell if you've got the two cameras in the correct order. When you press this button the first time, you heard the beeps from the camera. It's now in focus mode, and it set things up. When I press it again and release it, it took the photo. If you just want to don't want to do that, you can hold the camera up, press it down, leave it down until both screens go blank, because it's not doing that update LCD routine, and when you release it, it takes the photo. If you forget that you have to wait for the release, if you get in a hurry, then it will get out of sync, and you'll start thinking that something is broken. Really, it's operator error. Before, I had two slides on how to use the flash on it. It's now completely automatic, so you don't have to worry about it at all. Whatever mode you're in, it works. It has a couple of other functions, and I think that right now I've been talking to David Sykes about it because I get frustrated with it. I don't know what other people will do. If you take the zoom controls on this camera, and I flick one, and then I flick the other one, the blue LEDs come on. Now, if I press the shutter release button, it zooms until I release it. To get out of this mode, I go up and I half press that one, which turns that LED off, and I half press this one, which turns the LED off. If you full press it, you just hosed up the camera, so you're going to have to start over. In theory now, I can take a picture with the zoom on it, but it didn't work. It's supposed to work, it works sometimes, sometimes it doesn't work. One of the features of software that is hacked by people and that is an amateur effort is that you're getting their best efforts, which isn't necessarily always the best thing in the world. It has a sports mode that I think is real cool. You can go in and set the rapid fire mode in the Canon menus on this, and then you do that first press and it focuses and everything, and then you can take quite a few shots without refocusing or resetting the exposure on the camera as fast as the camera can write them. So it's real nice if you're shooting action with it. It also has an auto bracket mode you can go in and set up. It's a menu option, and it will shoot some number of photos with different exposures on either side of the one that the camera itself chooses. It's kind of fun to play with. It's easy to forget the fact that the camera controls, like the shutter releasing things, are also used by StereoData Maker. You absolutely have to read the StereoData Maker help file for your particular camera to figure out how it works. There are enough little differences between it that if you watch me using mine and you have the SD1000 camera, which a lot of people do, it's going to work a little bit differently and you're going to get frustrated with it. I thought it would be fun just to show some examples of other people's cameras that people have put together. So here we have Sheldon's, and it looks to me like it's mounted on the same kind of rack bar that I used from Jasper Engineering, with an old flash handle and a homemade battery release cable on the end. Very simple and straightforward. This is my favorite version of this. This Rick Schneider guy made this wonderful little faceplate. It does fix the interocular on the cameras, but it makes the smallest, neatest, most compact digital camera rig that I think I've seen to date. This is an LED flashlight with the button on the top and the wires coming out the bottom. I've seen 2 or 3 of these wandering around the convention, so I know people have got them here. This is an example of a switch that Pierre made, and yes, it is an anaglyph. I tried to get him to send me a flat copy, but I couldn't get him to. And you look, it's very much the same deal as the one that I built. This is a dual battery holder, so it actually has 2 batteries stacked on top of each other. It has a little power on off switch, so that you don't have to worry about accidentally pressing the shutter button. That's the little 5-volt regulator, the actual switch, and 2 homemade cables coming out of it. Now, this little switch is a remote control switch that Radio Shack sells. A little case with a little button in it. It's quite small. I didn't use it because I had the other one laying around. If you're trying to get different stereo bases, there are a lot of creative things you can do. That's a 45-degree front surface mirror. So one camera is shooting up, one camera is shooting across. I thought that was actually fairly clever, though this is the sort of thing that's too elaborate for me to carry around. I like simplicity. The thing I'm going to do next in StereoData Maker, these are Canon TX1s. TX1s do HD video, fairly decent HD video, 720p. Some of the examples that I've seen of it are pretty impressive. It's a current production camera, meaning you can just go out and buy it, about $500 each. And that's my next project with StereoData Maker. This is one where the camera, the batteries are in this little piece of plumbing type tubing. It's a button switch mounted on the side, and it's plugged into a piece of metal strapping. That's actually a metal strap intended for putting cabinets on walls for Home Depot. That probably cost about $1.50 to make, but it works just fine. The gotchas on this are always update all the files always delete all the files off your card before you update StereoData Maker. Now, I'm told that 1.7.2, the one that's coming out today or tomorrow, will do that for you automatically, so you don't have to worry about it. I think that formatting the card, however, is always a good idea when you're changing versions of this. And I cannot overemphasize the fact that if you let the battery voltage get low on these batteries, the cameras are going to start behaving erratically. They're still going to work, and when you first power them on after they've been setting for 30 minutes, they may work fine. And then 5 minutes later, 2 shots later, they're going to stop working and get very, very erratic. You do want to keep up with the new versions of this software. He's making changes all the time. Yes.
I mean, obviously, the batteries are independent of the camera batteries, so flash doesn't matter, it's strictly using them. About how many pictures do you get out of a set of batteries to know when to start watching it?
This guy is using 2 of those little lithium coin cells. When I was downloading this guy last night, I've shot about 600 photos on the first set of batteries. So if you shoot using the press release, let it focus and expose, and then press release again, you're only consuming power for the brief period of time when you have the switch pressed. I think a set of batteries in here will probably last for a couple of thousand photos. I haven't done the math on it though, so don't hold me to that. To end this up, if I were doing this right now, I'd do what I did to start with, pick an inexpensive setup, play with it, have some fun with it. Don't upgrade just because another set of cameras came out. You really need to stop and learn how this software works. It has a lot of intricacies to it. It has 40 menus. If you go into the menu mode on it, there are 40 menus. I've only touched on the very barest surface of how the software works. And of course, this is supposed to be fun, so don't let it get to be a big problem and a big hassle, which I think we all do all too often. I've got about 2 minutes for questions.
Why isn't this done for digital SLRs?
Digital SLRs use a completely different operating system than the little Canon point-and-shoot cameras, and nobody has managed to download that operating system out of the SLR so that it can be hacked and the changes can be made to it. And I suspect nobody ever will. It's a completely different world of software to run an SLR with it.
Why couldn't camera manufacturers provide it as software development kit or an application programming interface?
Because they don't care that we use stereo with it. We only buy a few hundred cameras a year and they're not interested. And also these camera people, in all honesty, they are incredibly proprietary about this software. They spend millions of dollars developing it. They develop all these special software tricks for doing things like faster focus, longer battery life, and those are highly proprietary, extremely valuable pieces of intellectual property. The people at Canon are probably freaking over this if they know about it.
Speak about it, let everybody know that that doesn't change the camera at all. When you take it out, it doesn't harm factory warranties or anything.
That's what I was trying to say originally with the software. When you load this software, it loads into the volatile memory part of this camera. You are not making any physical or firmware changes to this camera that won't go away when you take the batteries out. So if the warranty of the camera breaks, you can ship it back for normal warranty and repair. It's not like opening up a digital SLR or a point-and-shoot camera and wiring inside of it. You're doing nothing that modifies the camera. I think this is a wonderful bit of thing. David Sykes did a wonderful thing when he ported this over to it for us.
Just a comment to let people know that there's a Yahoo chat group that is tons of stuff daily on it.
There's a great Yahoo site for SDM. It was supposed to be on the handout along with the list of people you can buy parts from. Huh?
Parts of it.
The parts are all there, the place, which is a really hard part to find. But if you go out on the internet web and you search on StereoData Maker, you will find a link. It's StereoData, one word, space Maker. You'll find a link to this Yahoo group very, very quickly. I have one more question.
What was that? Say that you ordered the pre-made one if you want to.
It's called Digidat.
What was the question? Question is
Oh,
where-
I'm sorry. Where can you order the pre-made parts to build these things yourself? The website is called Digidat. Did we get that on the handout? It's on the handout. It's on the back of the handout. He has a variety of switches and Z-bars and camera rigs.
You mean DigiKey?
No, that's the part people. If you look on down,
The last one on the bottom.
yeah, the very last one is Digidat. DigiKey is a part
Oh, the guy in
source.
Germany.
Yeah, the guy in Germany. His stuff is extremely well made, by the way, from what I've seen of it.
Yes, there are.
Yes, there are. And that's it.
Yeah, there's more hidden. Thank you very much.
Thank you very much.
Steve. All right.